All right, on to the next page of the review. It says find the area of the following trapezoids and parallelogram. Now, remember, a trapezoid is a quadrilateral with one pair of parallel sides. Number 17 is a trapezoid, and number 18 is our generic basic parallelogram. So, 17. Remember the formula. It's going to be A equals 1/2 the quantity B1 plus B2 times the height. So the parallel sides are your bases, and the height should be perpendicular to the two bases here. So it's A equals 1/2 of 16 plus 6 multiplied by the height, which is 12. And your answer is A equals 132 square feet. Number 18, this is my parallelogram. Remember the base and the height, they're perpendicular to each other, okay? And opposite sides of a parallelogram are congruent. This is 10 meters, this is 8 meters. And if you want to find the perimeter, you would just add up all the sides. Very, very simple stuff, but we're just being asked to find the area. So it's A equals base times height. I only know the base, which is 10, but the height is my unknown. I can see that, okay, well, remember, these two segments here are perpendicular to each other. So I have 90, I have 60, so this leftover here, this angle is 30 degrees. So we're going to be applying special right triangles across from 30 degrees. This is A, across from 60 degrees, this is A root 3, and across from 90 degrees, that's 2A. So highlighting 2A equals 8, what does that mean? It means A is equal to 4. So this side here is 4, and this side over here is 4 root 3. The height is 4 root 3. Okay, so 10 times 4 is 40, slap on the root 3, and then we're dealing with meters, so the area is equal to 40 times the square root of 3 meters squared. That's 18. Okay, let's take a look at number 19. I know it looks kind of funky on my end here. This is 8 feet and this is 10 feet. Okay, so what do we have to do here? Well, remember, we're dealing with two types of figures for this set of problems. Trapezoids, parallelograms. This one is extremely weird, and I'm going to explain to you that this is indeed a trapezoid, okay? Remember, with a trapezoid, it's a quadrilateral, 1, 2, 3, 4, which has one pair of parallel sides, right? So if this segment is perpendicular to this side, right, and this segment here is perpendicular to that side, I just drew this 90-degree angle there, and then we can say that the slope of these bases are the same. So then, okay, what do I have to do? I'm going to use my formula. A equals 1/2 times B1 plus B2 times the height. I got A equals 1/2 of, well, I have 10 plus, okay, well, I don't know what B2 and the height are, so I gotta figure that out. But, y'all, I can see right here, this is a right triangle. This is 60 degrees, this is 90 degrees, and then this has to be 30 degrees. All right, so across from 90 degrees, it's 2A equals 8. So A is equal to 4, right? And then across from 30 degrees, this is A, so this side is 4. And then this side here, across from 60 degrees, well, that's going to be 4 root 3. All right, so let's highlight our players here. This is A equals 4. This side here is 4. The height is 4 root 3. this side over here is 8 feet, and then we have 10 feet, so this side has to be 10 as well. Okay? All right, we just figured out base 2, right? Base 2 is just 4 plus 10. That's 14. And then the height is 4 root 3. All right, so the height is 4 root 3. And I'm going to simplify this, so it's A equals 1/2 of 24 times 4 root 3. And we all know what's a half of 24. It's 12. You're going to multiply that by 4 root 3, coefficient to coefficient. So A equals 48 root 3 square feet. And there you have it. And if you're rounding, you should get approximately 83.1 square feet. All right, and then this is a trapezoid. So again, it's going to be A equals 1/2 times B1 plus B2 times the height. So A equals 1/2. Ooh, okay, I have 8, so let's put 8 there. Plus, base 2 is my unknown, so we're gonna leave some space here, and the height is just 4. All right, so then what do I do? Okay, well, this is what I know. If I were to do this, we know that this side is 8, and if I just draw some dotted lines there, then we have a rectangle. It's a parallelogram. This is 8, that's 8 as well, right? So then we know that the bases should be perpendicular to the height. So if this is 90 degrees and this is 90 degrees, as well as this and this. So across from 45 degrees, this is A. So this is A equals 4, right? The side here is 4. And this side here should be 4 as well. I'm just applying special right triangles. I'm skipping steps. I've already, done special right triangles in the past. So you should be able to, figure those little sides here of these two right triangles. Okay, so I have 4 plus 8 plus 8. That's 16. This side here is 16. So there you go. And then what do I get? I get A is equal to 48. No units involved, so I say units squared. Number 21, find the area of the following kites and rhombus. They share the same formula. A equals 1/2 diagonal 1 diagonal 2. So if I look at this, okay, well, this is my kite. So A equals 1/2 of 21 times 17. Okay, so 21. This is how long this diagonal is. I'm talking about the full diagonal there, as well as this diagonal, the full diagonal there as well. All right, so A equals 178.5 meters squared. Number 21 is that. 22, okay, you can see that we're dealing with a rhombus. All right, so remember this of a rhombus. The diagonals bisect. Okay, so that means that once these two diagonals intersect, they bisect each other. So this segment is congruent to that segment, and this segment is congruent to that segment. So if this is 6, that's 6 as well. If this is 4, this is 4 as well. All right, so how should I put this? Should I put it here? Okay, there we go. So we have 8 and we have 12. So A equals 1/2 of 8 times 12. So A equals 48 units squared. And then the perimeter, all right, well, what else do we know? To find the perimeter, I have to find all of these side lengths here. We have to know some properties. So the diagonals are perpendicular and all of the sides are congruent in terms of a rhombus. All right, so let's just do this. I know that this side here is 6 and this side is 4. And I'm going to draw a right angle there so that we have a right triangle. Can you see that right triangle right there? So we have 4, 6, and this is the side I'm looking for. We're going to call that C. A squared plus B squared equals C squared. So we're actually trying to find the hypotenuse, right? It's across from the 90-degree angle. So this is 6 squared plus 4 squared equals C squared. Take the square root on both sides. You're basically saying the square root of 36 plus 16. So C is going to be 7.2. So this side is 7.2, this side is 7.2, this side is 7.2, and that side is 7.2. Okay, why? Because all the sides are congruent when it comes to a rhombus, all right? So your perimeter is going to be 28.8 units. All right, so that's 22, number 23. All right, we're dealing with a kite here. So A equals 1/2 D1 D2. I don't see this 3.8 pointing at anything. All right, I don't see 3.8 pointing at this segment. It looks like the 3.8 is this whole segment here. So A equals 1/2 of 16.4 times 3.8, and you get 31.16 inches squared. That's number 23. Number 24, very, very simple. A equals 1/2 D1 D2. A equals 1/2 of 9 times 27. So then you get 121.5 square feet. That's your answer.